Number one, variables represent values that are. Oh, I don't know what this question even meant. Honest God, this was no. I really, and I'm not even going to re-record because this question was. I mean, the definition of a variable, of course, are unknown values, right? I should have taken this question off. Variables represent values that are unknown, and I don't know what what this person was thinking of for each situation. I would think it'd be like specific. It's not on your quiz. Don't worry about that question. Remind me to take that question off. Okay, next time I do it next year. Get rid of this question. Get 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 rid of question. No, I have not. I only had a cup at home. All right. Get rid of question. Number two, consider the situation algebraic expression below. Candy store charges $7 for an empty container. Then you will be charged for 75 cents per scoop of candy. The following model represents a complete cost of your shopping trip to the store. Notice I did that correctly. Said it. When asked what X represents, Eddie wrote empty containers. What's wrong with Eddie's response? Let's see. Empty containers are $7, so the X is empty containers. Um, they're being technical here. It's actually the number of empty containers. So next year we're going to get rid of this question too. Get rid of this question too. It's it's uh, it's being anal. Okay, three. I hope you guys won't be here. Number three, a health food store calculates the cost of your granola purchase T based off the weight of the cereal and the number of containers used. The customer will charge $2.25 for each container and 75 cents per ounce. The formula below represents the total cost of your purchase. What do the following variables represent? T was total cost, right? Granola, what did they call it? Granola purchase. Total cost. Total cost of granola purchase. And B, let's see, 225 for each container. So B is going to be the number of containers. Okay, they didn't say specific. And then W is going to be number of ounces, right? That's it. I'm done. I defined the variables.
Don't overthink that one. On our last summative, some of you guys just put down randomness. I'm like, oh, what are they doing?
Yeah, I
It's
think
obvious.
now this is going to be a retake on the quiz. Okay, this is 1.3 part two, right? Some of you actually tried to, I don't know, solve the equation in these lines. Yeah, just say what they are. That's all you have to do.
Don't overthink.
Okay, 4A. You are setting up a billing system for a coffee company. Your customers will purchase one commemorative mug for $8, but they will also pay $5.50 for each bag of coffee purchased. However, as a promotion, you are offering the first two bags for free. Write an algebraic expression that calculates the total cost of purchasing one mug and purchasing any number of bags of coffee. C. And then we have a disclaimer. Assume all orders ask for at least 3 bags of coffee. Don't worry about that. It's just a disclaimer. Um, so we've got what are we supposed to setting up a billing? Okay, so our T total cost is X. Write an expression that just an expression that calculates the total cost X of purchasing one mug. So the number of coffee bags is C. And how much is a coffee bag? 550. 550. So 5.5 is the cost for each bag. And we have to add to it the mug. So we're going to add to it the cost of a mug. Now, let's see, they probably do they want the number of mugs too? Yeah, we might as well put it in there. Okay. The number of mugs, $8 a piece. The cost of each bag of coffee is 550. But then we got this thing to worry about, right? The first 2 bags are free. So we have to minus 2 bags out of the cost of the coffee bags, right? So we're going to subtract the 2 bags, but we have to not just subtract the 2 bags, but the cost of the 2 bags, right? So we're going to need to distribute that 550. So there's my expression for total cost. $8 times the number of mugs plus $5.50 times the number of bags, subtracting the first 2 free ones. Make sense? Okay, so that's my expression. If I wanted an equation, all I would have to do is they should use total cost T because that's what we've been using the entire semester. That would be my equation. All right, 5A. Solve for B, isolating the variables. A lot of you actually, well, this class did really well. Yeah, this class did really well for this. I like to circle what I'm solving for. Here's my B. And as always, I like to put a dash line there. And we're going to get rid of the Q. I'm going to undo the Q, subtract Q from both sides. That gives me 4B equals 7P minus Q. Don't subtract those, keep them separate. They're unlike terms. Then I'm going to, let's see, I got B. I need B by itself. It's being multiplied by the coefficient 4, so I need to divide by the coefficient 4. So B is going to equal 7P minus Q divided by 4. Number 6, little b, little b. Here, I need to get rid of the denominator 4. So I'm going to multiply both sides by 4. So I get 4t equals, these cancel. I got 5b minus 7. I got to get to that b, so I'm going to get rid of the 7. Add 7 to both sides. Don't combine those. They're unlike terms. get rid of the coefficient 5. I'm going to divide both sides by 5. That 4t plus 7 divided by 5 equals b. 7, solve for big B. Here's a B, here's a B. Now these are on opposite sides of the equal sign, so I need to get them on one side. So I'm going to subtract 2b here. These are like terms. So I'm going to go ahead and put it right underneath there. 9b minus 7b is 2b is 7b minus 10. And I get 9y. See, want to get that b by itself. So I'm going to add 10 to both sides. Unlike terms. 7b equals 9y plus 10. And then get rid of that coefficient 7. So b is going to equal 9y plus 10 divided by 7. And the last isolating problem, which one haven't we done yet? The undistributive thing, right? That is technically not a math terminology. I'm solving for big A, and I need to get them on the same side of the equal sign. So I'm going to subtract, let's see, I'm going to subtract AM. It doesn't matter. You can add 4A or subtract AM. I got to subtract AM, but they're unlike terms. Okay, so I get, let's see, 6B, bless you, minus 4A. I should have added 4A. Minus AM equals 5. Yeah, would have made it positive. I should have done it the other way. That's all right. I'm going to subtract 6B. So I get negative 4A minus AM equals 5 minus 6B. Now I've got A in two unlike terms on the same side of the equal sign. Means I have to undistribute, take out that A. Negative 4A divided by A is just negative 4. AM divided by A is just M. And I have 5 minus 6B. And then we want to divide by everything we don't want, which is negative 4 minus M, negative 4 minus M. So A is going to equal 5 minus 6B all over negative 4 minus M. Now, if you did it the better way, the smarter way, and added 4A and subtracted 5, you'll get a different answer, but it's actually the same. You'll get 6 or negative 5. All the signs would change. Plus 6b over 4 plus m. Okay. Either way. Questions? The whole idea here is when you have unlike terms on the same side, undistribute. Questions? Comments? Concerns? 1.5 inequalities. Now, these are simple inequalities, whereas when you get down to like 15, that's a compound, or even 13, it's a compound inequality. Okay, so you got to be a little more careful. Simple inequalities, just go ahead and get the variable by itself. Going to have to distribute that negative 8. So I have 34 plus 3x greater than, let's see, negative 8 times negative 6 is positive 48x. Negative 8 times positive 7 is negative 56. I'm going to keep my x on the left hand side because it's easier to graph and shade. So I'm going to subtract 48x from both sides. And at the same time here, I'm going to bring the 34 to the other side. So I'm going to go ahead and subtract 34, subtract 34. I'm going to do this all in one step. It's all addition and subtraction, so I'm going to keep the sign. It's greater than or equal to. Okay, these cancel. 3x minus 48x is negative 45x. You see, these cancel. Negative 56 minus 34 is going to be negative 90. Divide both sides by negative 45. These cancel. I get x. Now, I divided by a negative number, so I have to flip my sign. I reverse it, and I get 2. So there's my inequality statement or solution. Graph it. Well, there's my number line. See, I got 2, one bigger, 3, one smaller, 1. Um, because I kept my variable on the left hand side, I know I'm going to be shading to the left, where all of those numbers less than 2 going out to negative infinity. And it gets a bracket because it has an equal sign. Interval notation, negative infinity, comma 2, bracket, and infinity always gets parentheses. Okay, I'm going to go skip down to 13. All right, 13 is a compound inequality because you have two inequalities there. Okay, this one happens to be an and statement. So it's going to be an in between when we go to graph. Either bracket or parenthesis, and it's going to be in between. It's and statements. So let's go ahead and solve for v. Let's see, I need to solve for v, so I'm going to add 8 to both, and I'm working both inequalities at the same time. So add 8, add 8. Negative 50 plus 8 is negative 42, less than or equal to. These cancel. I get my 6v less than or equal to negative 20 plus 8 is negative 12. Divide by positive 6 because I'm dividing by a positive number. The inequality stays the same. Negative 42 divided by positive 6 is negative 7, less than or equal to 6 is cancel. My v negative 12 divided by positive 6 is negative 2. So there's my solution or inequality statement. Graph it. Smaller number on the left, negative 7. Bigger number, negative 2. I know it's going to be in between because it's an and statement. And this one gets a bracket because of the equal sign, negative 7. Negative 2 gets a bracket because of that equal sign. So interval notation, bracket, negative 7, comma, negative 2, bracket. Or statements, I know they're going to go opposite directions unless they overlap, either bracket or parenthesis, and they're going to go out to their infinities. Okay, this time I have to solve them separate. They're not squished. So I'm going to subtract 4. Subtract 4. I get negative 3k. It's less than negative 20 minus 4 is negative 24. Divide by negative 3. I get k. I have to flip because I divided by a negative number. K is greater than negative 24 divided by negative 3, positive 8. Bring down my or, solve the other one. See, add 6, add 6. I get 5k is less than or equal to negative 50. Divide by 5. Divide by 5. I get k is less than or equal to negative 50 divided by 5 is negative 10. Graph it. See, my smaller number is negative 10. Bigger number is 8. I know I'm going to be shading the both ors. So all of those numbers greater than 8 or follow the sign. No equal sign, so parenthesis. All of those numbers less than negative 10 or follow the sign. And this one gets a bracket because it does have equal sign. Going out to infinity, going out to negative infinity. Interval notation. Let's see, negative infinity, comma, negative 10, bracket. This is my union symbol here. Parenthesis, 8, comma, positive infinity, parenthesis. And that's my answer. And then we did what, 1.6 part 1? Oh, absolute value equations. Okay. We even give you a hint on the quiz. Absolute value have to use two problems or two solutions. In order for me, now remember, absolute value is distance, and we're trying to figure out where the location points are. So we have to consider both cases of 10x minus 4 equals negative 34, or the 10x minus 4 equals positive 34. Here's our two problems. Then we have to solve them. Add 4, add 4. I get 10x equals negative 34 plus 4, negative 30. Divide by 10. Divide by 10. So I have x is equal to negative 30 divided by 10 is negative 3, or add 4, add 4, 10x equal to 38, divide by 10, divide by 10. So x equals 38 tenths, which can be reduced to 19 fifths. There's my answer. And before you can split them up, always make sure your absolute value term is isolated. Okay. So you're going to have to add 7 first. So I get the absolute values of 9p plus 5 equals 7 plus 7 is 14. Then split them up. 9p plus 5 equals negative 14, or 9p plus 5 equals 14. Subtract 5, subtract 5. I get 9p equals negative 19. And then divide by 9. So p equals negative 19 ninths, or solve the other one. Subtract 5, subtract 5. 9p equals 9. Divide by 9. A lot of nines going on. So p equal 1. Questions, comments, concerns? Nothing? Nothing?